We're live. Hey everyone, welcome back to today's live stream. My name is Kit and I am super excited to have you guys here with us. We're going to be doing a powerful deep dive on one of our most important emerging needs in the Web3 industry, which is the privacy on demand across any chain. So today we're going to be exploring how developers can enable privacy preserving feature like age check or identification verification or basically inside any D app or any blockchain without leaking user data and without changing the existing UI. We are here with our amazing builder Upendra, who's going to be leading the demo and walking us through to the show today. Of course, like always, if you have any questions, you just want to have fun, want to say hi to us, drop it down in the chat below, and we'll answer them as we go through the night. And without any further ado, all right, Upendra, can you walk us through how how we're gonna be running this demo tonight? Quickly introduce yourself and yeah, take the mic.
Thanks a lot, Kit, and welcome everyone. I promise it's gonna be a really amazing live stream. You're gonna learn a lot. It's just because we are talking about a very important feature of the Web3 technology, and COTI is providing it. That is privacy. As we know, the Web3 technology ecosystem has grown a lot, and the liquidity is segregated around different chains, so it's really difficult to create a chain and create a product, and the user base gonna be limited. So in this live stream, privacy on demand, we can also cater with this problem. So in this live stream, I will mainly focus on the development. I'll show you how I developed a dapp. I'll show you how it works and what features I have used there, and how you can create similar dapp for yourself using the privacy on demand of the COTI. But just starting the development, first I want to talk more about the privacy on demand feature to give you a brief understanding what I actually am talking about and why we both are so excited about it. So COTI is setting a new standard for the privacy in Web3 with its new cross-chain privacy on demand feature. COTI allows user dApps and enterprises to add privacy to their transactions whenever they need it. Whether you're looking to integrate privacy into an existing project or planning to build a new privacy focused solution, COTI makes it possible. The best part, there's no need to change the existing tech stack. Whether
Wow.
you whether you're building an EVM or non-EVM chain, COTI act as a universal privacy layer that fast, lightweight, and easy to integrate. Privacy is now flexible, scalable, and ready for the real world of Web3. Now let's see how it actually works. So I'm gonna share my screen with you guys to show like a diagram how it actually looks like. Just give me a sec.
Okay, I'll add to the screen and
So here it is. As you can see, COTI blockchain gonna be a center for me. As I can see, COTI blockchain looks like a center of the privacy for me. Any blockchain or any project on any blockchain can connect with the COTI blockchain, can depend on the COTI blockchain for their privacy requirements, privacy need. What they just need to do, they just need to create a smart contract and deploy it on the COTI chain, which handles all their private data and privacy needs.
sorry to cut you off, Upendra. We have a question from Anor back 1254. He says, when will the currency be distributed? Do we have any an ETA on that?
I don't think I have the answer for that.
All right. Yeah, we'll let you know as soon, as soon as it's dropped. And yeah, please stay tuned to the social medias.
Yeah. So if you continue, like to use the privacy on demand, any chain which and on which chain we can deploy a smart contract, we can use the privacy using the COTI blockchain. What we need to do, uh, like other chain connects to the COTI to store, utilize private data securely. You don't need to shift all your ecosystem. Like whenever a layer 2 or layer 1 launch, what they provide a facility, they provide the utility, but you need to shift whole of your ecosystem and user base to that chain. Here you don't need to do that to utilize the privacy. You just need to create a smart contract on the COTI chain, and you can utilize from that chain, from that platform directly. I'll show you that in this example. If I move and so you some context, just try to give the context. You, if you have a quite understanding of the blockchain technology and how the smart contract and decentralized system work right now, so you can connect the COTI ecosystem, and you can connect here and understand the decentralized nature of it, of the privacy on demand ecosystem, or the architecture, how it works. So let's suppose you have a smart contract on any chain. So in the first example here, you can see the inter contract communication, we call contract call. So if you have two contract on a chain, you can, your contract can directly call each other. They can connect each other, and share the storage as well as the business logic with each other. So here, if we connect or try to understand with the CODI, you have a smart contract already on a chain. You can deploy another contract on CODI chain. Now the contract can call with each other. Now you can ask me how it can be secure and decentralized.
Mm,
So for that, we need to use a layer, interchain communication layer like Hyperlane here, which
mm,
provides you a decentralized cross-chain communication. What Hyperlane actually do? It have a smart contract on each chain, which is called the mailbox contract, which basically
mhm,
takes the mail from one contract on a chain and deliver it to the another contract on another chain with decentralized and secure manner. So we can depend on the Hyperlane, or if you want to, if you require, if you have such use case, you can create this interchain communication layer by yourself. It will increase the certain amount of development complexity, but it will make it more secure for your use case, because you want to make this private, you don't want to share
mm,
the endpoint with other. So it's up to you. You can utilize the current services, decentralized services like Hyperlane and many more present in the market, or you can utilize or develop by yourself. So these are the option available here. Now let me take you to the example, a quick demo I have created, so I can showcase how it actually works. Mhm. Okay, let me open here. Yeah, so basically what I have created, it's a simple demo for the IDAO. What is say like identity verification DAO,
mm,
decentralized automation organization. So what
mm,
I thought, if someone is going to use the privacy layer, COTI as a privacy layer,
mhm,
what I thought to create, I create a simple dapp which stores the user data. Any user can come and store their information which is which is confidential.
mm,
They don't want to share with anyone, but these information are required in so many web3 projects, like the age of the person and the identity of the person. To verify it, at some
mm.
point you need to have the system to verify the identity of the person. So I have
Yes.
created it here. I have created it on the COTI. And
Mhm,
how you can create it, and what I have added here is, I have created a smart contract which stores the user data. And who can store the data? Like user can only come and store its data. Before storing it, he needs to encrypt the data, which data he wants to be secure,
mhm,
using the user key provided by the COTI blockchain to them. The user key of the person, what it do, it encrypts the data, and then the user make the contract call and store that data. So now the data is encrypted by the user key of the user, so no one can read the state can go and fetch the state of the user data, but they cannot read it because it's encrypted. And also, COTI provides the computation on this private data. So I have created this contract which provides the APIs or the functionality. So any platform from any chain or anyone can make a, you know anyone can make an external call and
Mm-hmm.
ask the contract if the user, some functionality, if the user is above 18. So the smart contract is not going to directly give the age of the user, but it's going to do the calculation on the user data. Now anyone or any platform can know that the user is above 18 but cannot know the age of the user. So there are, logics you can build on the COTI blockchain using the smart contract. You can think about so much, like the address of the user or the identity number of the user. Any data can be secured here and can only be fetched which is by the platform or the contract which is whitelisted on this KYC platform I have created, or the permission provided by the user only. No one else can even fetch that the person is above 18 or not. Only the
Mm.
platform we gonna be whitelist on our on this system, on this IDAO, or user whitelisted it, can do that. So let me just show you quick demo what I have created. There is
Of
a
course.
KYC portal. So here I have added one functionality. User can come
Mm.
and add their date of birth. So let's suppose this is my, so I'm connecting it first, and it says like for this address my date of birth is already set up, so I have already set up the date of birth. Here I have added a use case which is voting. So this voting page is actually
Mm-hmm.
on the Ethereum. It's not a smart contract which is on deployed on the Sepolia of Ethereum. So this platform can directly call if the user is above 18. That's if this returns from the COTI is like yes, this is above 18, he will be able to eligible to vote. So
Mm.
when we trigger it,
Okay. Oh, it connects to MetaMask.
yeah, and it will trigger the, so as I say, like cross chain verification triggered, and it takes some time because it's cross chain. It go to the COTI blockchain and check and return from it. We can also check the transaction from the Hyperlane, as actually we are using the Hyperlane here. So it will show you the message here, the original chain and destination chain in some time, and we just need to check here for the verification. It takes some time. Let's between then go to the explorer and check some another transactions I have just made before to showcase in the demo, because like it takes some time. So this was our transaction we have made from the Sepolia, as I said, and this is the transaction. These are the transaction I have made
Mm-hmm.
some times ago. These are the transaction, as you can see, happen. And as you can see, I have made the transaction from the Sepolia in the Hyperlane Explorer. Says the transaction originated from the Sepolia and goes to the COTI blockchain. So you can check all the information from here, and we refresh it again. As you can see, the transaction has been shipped from the Sepolia and it's going to the COTI blockchain. So it's taking quite time. Sometimes it's like due to the gas congestion and all. Will Now, this was the part of the demo, how it gonna look like, how many things you can build. But now let me show you the exact contracts and how I have built it. So you're gonna have some idea how you can build it in the COTI. So let me just open it.
Uh, what am I looking at here? Are we doing? Are we going to be using V0 today?
For that, I'm using cursor because like it's
Mm.
kind of most of the contract or backend task.
Mm.
So we'll be using cursor for now for the smart contract development part. And as I have shown you the demo, that
Yep.
was built using the V0. So actually, if you can see,
Yep.
this is a backend I have built.
Mm.
The demo have shown you. So I actually built two smart contract. One is private data requester. So the that e-voting contract I was shown you. This is basically asking the private data from the COTI, and this is the verifier. This contract actually receives the message from Hyperlane mailbox contract and return the result. Do some calculation, return the result to the requester. So as you can see, what we have done in the requester, this is a very simple demo, and I have created just
Mm-hmm.
one function to check if you are above 18. This is a
Okay.
contract which is on the Sapolia, and we are making a transaction over here. It basically what it does, it just transfer my request to the, as you can see here, mailbox.dispatch. So this is a function of mailbox.dispatch of the Hyperlane. It calls the Hyperlane here, and Hyperlanes take this request and send it to the COTI, to my smart contract. And how it knows where is my smart contract is.
Mm-hmm.
So first of all, let me show you. I'm using this mailbox and uh, this interface from the Hyperlane, and I'm also using this Hyperlane library. So the use case and the requirement of this contract is just to deliver the transaction over there. And then what Hyperlane says, because we are connecting through it, you need to create a handle function which actually takes the origin and sender from the Hyperlane,
Yep.
and then using that data to make a call using the data to your smart contract functionality. And what functionality it is calling, process the age verification. So what this process age verification is actually doing, if we go and try to find out, this is a function. It basically decodes the account, like the address this transaction come from, because
Mm-hmm.
that's why it's gonna map out the get the information of the address. So this will take the address of the user, and then it basically what it do, it go to the let me check where it goes and where can it found the, yeah. So basically what it does, it is figuring out, making a calculation on the data. Which data? So there is a data, yeah, this is date of birth. So this is the date of birth data actually saved on this contract. This is a COTI contract here. And how this data come from, so as I have shown you in the example, when, let me show you again, when you go to KYC portal and encrypt and submit your data, okay, when you encrypt and submit your data, it will call this functionality.
Mm.
And where this functionality is, so set date of birth, basically it takes the encrypted data and set it to the smart contract. So this is how it works, and this is how simple it is. It's because most of the interchain communication part is handled by the Hyperlane itself. So you just need to understand the contact development, and it's
Mm-hmm.
really easy to really easy to apply using the Kodi blockchain. Now
Yep.
let's see how we can develop it. Like if we go and try to create a simple smart contract, so what we can do, I have created a simple project here, pod demo. And what we can do here to make it quite fast, like your AI tool, we are going to use the AI, understand it clearly. What we can do, we can take a COTI Hyperlane template, sorry, COTI harder template, so that it can basically clone that repository. It have a simple example of smart contract, so it gonna have the understanding of the smart contract from there.
Mm.
So we simply go and clone it from the COTI repository. We go and do git clone. So basically we have a simple smart contract. Just it has one function which stores the encrypted number. So what we can say here, we can ask it to create a smart contract which have two functions:
Mm.
shave date of birth of user, and second is verify if it's above 18. And we want to save the date of birth of user in time lock manner, timestamp manner.
Okay. So basically, what happened here is the let's say if it's the verification of the date of birth, it wouldn't show the date of birth. It will just kind of scan through and see that, okay, if it's above 18, then it's a yes, and if it's not above 18, then it's a no, right?
Yeah,
Just okay, it's more like a true or false function.
yeah. So now let's wait for it to create a smart contract. Basically, our smart contract is giving two functionality. What I
Yep.
ask from it, just give a function to so the user come and store their date of birth here in the encrypted manner. And there another function, when the function is called, it can check if the user's age is above 18 or not.
Yep.
And let's see, like, if our AI tool is able to do it. I believe it can do it. Let's just wait for some time.
Yep.
So it's kind of updated the same contract. That's okay. It's removed the older logic and created a smart contract age verification. It's saving the user's age in the CTU64. That's also good. And it has calculated the timestamp of the 18 years. So like, what is this 18 years in the second mean? So it converted it to here for the calculation. That's also really good. And there is a functionality which is set dob, and it is taking it type, which is a basically encryption type of the COTI. So it only takes the encrypted data from here. That's also right good. And now it's going to call the validate ciphertext function. It's basically going to validate if the encryption, the person who is encrypted is really the person who
Yep.
has signed this transaction. And then it's going to basically save it in the smart contracts.
Mm.
And now let's check if it's verification. While it comes to verification, it's taking the threshold timestamp. Okay, let's calculate threshold block time 18 years. Okay, so it's asking the encrypted input. We don't want that. We don't wanted that. We can always ask it to update it. And it's also giving you the functionality to get the date of birth in the encrypted format. Anyone can read it. Anyone can get it, but can't read it because it's gonna be encrypted, and only
Yep.
user can decrypt it. And has birth dates set, and it's also checking if the user have already set the date of birth. Okay, that's also
Yep.
a great functionality. And it is still building, so let's just wait. Okay, it's also updating the test cases file and deployment file for us. Good.
Okay.
And we need to create an env file like this one. So we have given, it's already given a env file. We, so basically here we provide our secret keys.
Yep.
I will provide my secret keys here, but I don't want to show it, so I'll minimize this. You can go and paste your private signing key here, then the public key and the user key. If you don't have the user key, you can leave it. This script going to onboard it by yourself. So
Mm-hmm.
let me quickly grab my I have, I think I'll pick it from this project. Okay, it's kind of stuck somewhere. Okay, I just wanted to make my private key secure, but because I have used it many
Many times.
times.
Right.
Yeah.
Uh-huh.
So we'll, for now we'll keep the, okay, I'll also paste my user key to make it
Mm.
fast. But if you don't have, you don't need to paste it here. And now let's check the smart contract again. So we have this smart contract.
Yep.
I find it perfect. What we can do, we can change this as, yeah. So I can, if you press Control L, it will copy it here. I
Mm.
want you to update this function. Take user address to check if he is above 18,
Mm.
and take what we can say, and take current timestamp for comparison. Let's see if it can understand it. So it is taking the user address now and current timestamp, and yeah, it's kind of hallucinating right now.
Mm.
It actually asking me to provide the encrypted timestamp, current timestamp, and the 18 years in second timestamp.
Okay.
So what we can ask it to do, so let's just try to understand what is actually trying to say. Take user parameter, take current timestamp, pass the current timestamp encrypted value. Okay, Let's try once again.
Yep.
Not needed to call the. It's not needed to call the. Needed to provide the timestamp. Just take one parameter, which is user address, and rest can be fetched from chain.
Mm.
So let me try to be quite more technical. I'm just asking it to fetch all the information from the chain. Just ask the user address from it.
Yep.
As it may understand right now, like block timestamp. Let's check. And in the set dob function, now I need to check if the set dob function is the correct or not. Okay, it's taking the but timestamp. That's correct.
Mm.
Let's see if the cursor is able to do that. And meanwhile, I want to show, like, if you want to understand like more the how Hyperlane is interacting
Yep.
here. So if we go and open the Hyperlane documentation, there's a uh, there's a part called message send message. If you search on that, it gives you a very quick example. There is a function in the mailbox contact of the hyperlink. So
Yep.
mailbox contact is present in all the chain, and if a chain don't have the hyperlane mailbox contact, you cannot use the hyperlane in that chain,
Of
but it
course.
supports most of the chain. So basically from your contract you are making an interchain, or not interchain,
Mm.
it's an inter contract call. You are making an inter contract call from your contract to the hyperlane's mailbox contract, and hyperlane provides a function to basically call, which is called dispatch.
So
It,
do you mean the two contract kind of intercepts?
yeah,
Okay.
kind of interacts with each other in the chain,
Yeah.
and it's really common in a chain. When you
Mm.
deploy or build something in a chain, it's kind of compact, secure,
Mm.
decentralized system. So any states can connect between them, and they are, because they are verified by the validators on there, so they can
Yep.
connect over there and make a call and make a transaction between each other. So that's really
Mm.
common. So that's what you really need to do. You need to call the dispatch function of the iMailbox contract of the hyperlink provided on all the chain. And if you want to know the address of that iMailbox contract, there's a list provided by the hyperlane here. As you can see in the documentation somewhere, also in the GitHub repository, they have given the
Mm.
complete list. But the quickest and the easiest method I use, okay, this is our transaction, like which was like waiting. Okay, let me check. It has gone, but it's completed. As you can see, it has taken 11 minutes,
Yep.
but it's completed. So if I see, I need to show you here, go to the explorer
Mm.
and type your chain. Let's suppose you want to find out the COTI mainnet. For the COTI mainnet, so go and open the COTI mainnet. You can find some transaction over here. When you open the transaction in the COTI side, you can see the mailbox contact address. You can copy it from here. Okay, so this is the
Mm.
contact you need to call, and how you need to call and what all the informations you need to provide in here. This is, you gonna call the dispatch function. It requires destination domain. So
Mm-hmm.
this destination domain actually says on which blockchain you want to make the transaction. So if you are making the transaction from the COTI to the Shapolia, it should be the chain ID of the Shapolia.
Mm.
And if you are calling it to the other chain, it should be the chain ID of that chain. Here you need to put the recipient address, which address will receive this call. This is the contract which will be receiving the call on the target chain, and
Mm.
this should have a handle function to handle this call. Otherwise, the call going to be fail. And this is a masses body. Actually, you need to encrypt all the masses or the function name signature you want to call on that contract. You need to encrypt and put it here. Okay. And in return it will provide a message ID. This is the message
Yep.
ID. This is the message actually, ID which is you are going to share, like I have searched here. Okay. So as easy as it is, so this is really easy. There's a one trick, as you can see in the example. Whenever you put the contract address, you need to make it put some extra zeros here to make it byte 32 type. So you need to make it byte
Uh,
32 type. That's the trick here. But there is also a trick here. If you are
what
going
does the
to,
byte 32 do?
basically this is the size of like the parameter it is taking accepted by there. So basically it deals with not with the only EVM chain, it deals with the Solana and other chains too.
Mm.
So these have different address sizes. So there is
Okay.
not on the Solana, the smart contract size maybe have different. So this is to normalize all the addresses. They have put it here, like maybe Solana have the size of the address will be
Uh,
here, so they're gonna be have extra zeros here. So the size they're gonna
okay.
receive going to be same.
Like some chains has 12 and some chain has 24. This
Yeah,
one
exactly.
requires 32, right?
Yeah, exactly. That is.
Okay.
So this is what you need to do. This is the way, and this is the simplest way. But when we you deal with the COTI, you need to provide some extra fees. When you see here, when you are calling a dispatch function, you need to pay some fees here. It's a payable function.
Yep.
Basically, to transfer your transaction to other chain, the
Mm.
Hyperlane need to pay the fees to other chain on your behalf, the transaction fees. So you need
Yep.
to pay the a value here to Hyperlane to compensate Hyperlane. And how much you need to pay? You can call the code dispatch function,
Mm.
and this code dispatch function, before dispatch there is a code dispatch function provided by yeah, this is the function which gives you the exact fee you need to pay.
Mm.
Okay. But sometime if the calculation and the call is really heavy on the other side, in
Yep.
that case your transaction still may fail because you may have paid a lesser fees, and the code function may have send the lesser fees. In case of quote it happen, then what you need to do, let me show you. I have involved that in the example. And okay, let me take my example here back. That's not like this is quite a complex thing, so yeah, I cannot develop it right now here in the meeting. That's why I have created this example to show you, because this is the point you're going to be stuck with.
Mm.
And here, before calling the mailbox dispatch and before quoting the, you can easily quote the fees in the contract itself. You can also provide a fourth data. In the dispatch function, I have shown you only three data, three parameters, but you can also
Okay.
provide another parameter called metadata. What this metadata have? The number of ETH value for the message,
Uh,
and the estimated gas limit. So you can increase the gas limit
mm.
from here. So if you want to provide a higher gas limit so that your transaction don't fail there, you can put the higher gas limit here. As you can see in the transaction, I am providing this gas limit.
Yep.
I'll basically do what I calculate the code from the code masses, and then I provide 10%, 20%, and 50% extra fees there. How I provide that, I can also show you in my.
Is the metadata connected to the MetaMask?
No, this is a metadata required by the contract of basically the mailbox contract required this metadata.
Okay.
Is just provide to provide you extra functionality or flexibility if you want to, just don't providing a standard simple function. It's provide with the metadata you can enjoy the flexibility of the hyperlane and provide the information what you require. As you can see,
Yep.
like you can increase the gas limit on as per your requirement. And if you can see the sending script I have created, what I am doing here,
Mm.
I am increasing the fees, the code fees. Like this is the fees I got from the calling the mailbox contract,
Mm.
and then I'm increasing it by the 10% buffer, and still it have taken. Okay, I have provided the 10% fees. Still it has taken. You know, uh, not this one. Yeah. Okay, now it's showing less, but it has taken 11 minutes. I have shown you earlier. Okay, so how and why this happened is just I have provided only 10% extra fees. That was not enough, so I should
Mm.
have provided 50% more fees. So there is how you can deal with this method, this gas problem. uh,
Mm.
you can provide the extra fees to make your transaction faster. It also depends on your use case. So let's see what our contract has built. So now it's taking the user address and basically current timestamp with the
Mm.
18 year seconds and dividing it. And if okay, so it's kind of taking the current timestamp
Yep.
and dividing it to the 18 years, and it gives you the threshold timestamp. And okay, where it gets the threshold timestamp, public to GT.
Mm-hmm.
And where it is utilizing the user's date of birth. Let me check. So here it is taking the user's date of birth, and let me check if it's utilizing it. Okay, yeah, it's taking the user's date of birth,
Yep.
and it is taking the GT threshold, and then it's trying to calculate it here. Okay, so let's just move on and try to figure out if it's right or not. Try to deploy it and build something on it. So what I'm going to do, I gonna ask it to deploy on testnet and call the set function. So basically it already have updated the deployment script.
Yep.
Let's just check if it can. Okay, it's doing a different thing. Just ask it to deploy it. Contract testnet and create testing script. So let's see what it actually doing in the deployment script. Setting
Yep.
up the account, getting the contract, and then deploying it, age verification factory, and it also calling the contract,
Yep.
age verification 18 year in second. Okay,
Yep.
let me check the contract. What is this 18 year in second means? Okay, okay, it's fetching the timestamp from here. No
Yep.
problem. Actually, it basically testing if like after deployment the state was updated correctly or not. So it's kind of automatically running the deployment script, and
Yep.
when it finds out like we didn't involve or install the npm dependencies, so it's doing it by itself.
Mm.
That's cool. And I'm using this cursor in the auto mode, not in the premium. Like I have the premium, but I'm not using the premium models here because
Mm.
my package has not, like I have used all the premium model in 1 week, so I don't have that credits right now. So
Yep.
still it's doing great with the auto mode. Basically in the auto mode it use
Mm.
the lesser models, not the sonnet 4 or more.
No, but it still works, right?
Yeah, still works.
Yeah. I mean, that's good because at least it shows that you don't in order to do this you don't really need a lot of money.
Yeah. And if you are like a developer or you are learning to development, you can
Yep.
also learn it from here. Like it's like a, you have a mentor with you, you can ask the
Correct.
questions how it's doing it, what it actually means, and it gives you all the answers. That's also
Correct.
cool. Even I utilize it a lot, like I take so many answers from it, like
Mm.
to make my development process faster.
Makes sense.
So as it says, like contact deployment has been successful. This is
Mm-hmm.
our contact address. We can also go and check this address on the testnet if
Yep.
it's hallucinating or correct. I have copied the whole. Okay, it has a transaction and it was 46 seconds ago. So contact was created 46 seconds ago. Now it's calling the contract with the script it has created. So it's all automatic.
Mm.
Okay. Yeah. It's also finding some errors here and fixing it by itself. And now it's providing me the summary. Let me zoom it if it is visible, or I can zoom it more.
Mm-hmm.
So if we see the summary, this is our contact address after deployment. This is the deployer. That's correct. This is the
Yep.
transaction it has made.
Mm.
And it has saved my birthday to 1 January,
Mm.
which makes me above teen, right?
Correct.
And then it verifies the birth date saved and it was successful, and then
Yep.
it's go for age verification. It was successful and guess very age verification completed. There are two scripts
Correct.
created and you can run this script by yourself. Let's check and try to run this script. So what it says, okay, so it says like no hardhat config found here. Okay, we
Mm.
are not in the current, actually we need to go into the COTI hardhat template folder. Now try to run it. So it says like testing, check if the date of birth is set, has been set.
Yep.
Okay. Second test, save date of birth. Now it's trying to save the date of birth again. Test
Mm.
the verified date of birth was saved. Test, it's verifying this. So the time has been saved and expected this and match this and verifying age. If above 18, getting threshold timestamp, encrypting
Mm.
threshold. And now it's trying to verify the age for user. He's just like hypothetically creating a user and trying to verify,
Mm-hmm.
and it says it should have reverted and it's reverted. So it kind of tested all the functionalities, but I what I want to show you guys, let's just open the transactions again. These all the transactions I have created right now. And You can check.
Mm,
This is the transaction when person call for to save the age, and this is the input data anyone can
mm.
check. Like anyone go and try to fetch the age, and this is the data. They will
Okay, so they can't they can't
kind
know.
of it's kind of jumbled and encrypted.
Mm,
No one can read it.
yeah.
Okay, so this is how it works. But let's go and check out the script from ourselves once more. What actually it does.
Mm.
So IT birth timestamp encrypt the value.
Just out of curiosity about that the data that you showed me just now, that's encrypted. If you copy that and you throw it into, let's say, another AI agent, like would it be able to decipher what it says, or it's just basically like gibberish language to them?
The data, yeah, like if anyone who don't have the encryption key like the user
Mm,
have, they can't read the data. It's kind of
okay.
going to be encrypted for them. They will get to find out so many a value which is unable they unable to understand.
So
So
even AI wouldn't be able to understand, right?
no,
Oh, okay.
because like AI also do computation, right? And
Mm,
uh, we cannot decrypt the data without the user key when the machine can't do that.
wow.
So which
So your
it says like
privacy is very safe. I mean, on blockchain compared to like let's say if I don't want to get political, but like it's if you talk about like in real life, it's like every time when you travel with a passport, anything, it's like I think like blockchain is more safer than actually you holding onto the passport yourself.
yeah, you're right. And now like this is example how you can create a contract verifier here.
Mm,
But now let me give you an example, a quick example demo how you can create connect it with the hyperlane. So
mm-hmm,
what we can do, we can create another simple contract, because I think if I try to implement it here in this contract, it can is kind of start hallucinating. So let's just create another simple smart contract,
yep.
which basically utilize the hyperlane and call the mailbox contract first.
Mm,
So for that, what I gonna do, I come here and ask create another smart contract using Hyperlane. So basically, it calls Hyperlane mailbox contract and make transaction. So I'll just create a simple one.
yep.
I'll take some context from here. So this is example. Let's figure out like if this AI tool can find out, and like this is easy. I think it can find out. Let's just check, and we can also provide some information as a context here, which I think it's necessary.
Mm,
And I want you to make call on Shapolia. So I'll make call on the Shapolia, and for that, what we need to do, we need to provide the mailbox contact address of the Shapolia
mm,
and this chain ID, and we also need to provide a address who has this handle function. So for now, we can utilize my contract which have the handle function I have created earlier.
mm.
So this is mailbox contract. and domain. Let's see like if it can figure out by mailbox contract the domain of the Zapolia by itself, because it's really common. And what we can say, sender. Let's see, this is the domain. This is recipient. Make it by 24 type. So I kind of provided a small context, not a very good one,
Mm-hmm.
but I think it can figure out by itself because it's really simple. Let's see.
Okay. Hopefully, it doesn't hallucinate. Okay.
It has created a mailbox contract interface. Okay. And then a hyperlane contract, hyperlane sender, basic contract. It has a constructor which takes the mailbox and recipient, and what it do with the recipient. Let's see, it converts into the byte 32 type.
Hmm.
Let me check if that's the right way. Yeah, that's the right way. Good. And it has a send message which send this message. It should also show the domain, destination domain,
Mm-hmm.
where it's getting its destination domain. Okay, so it's created two functionality, one with value, one without
Hmm.
value. And in the send message to recipient, it is asking the recipient from me
Mm-hmm.
message ID, then recipient, then message body. It is converting the recipient, and what is the message body? Okay, it want me to provide the message body. So it has created some script for us. First one is deployment. It
Yep.
want us to deploy the script, so we're gonna keep all the functionalities. It's kind of created a generic function.
Okay.
Okay, so while deploying, we face some challenges.
Hmm.
We can figure out and also ask like AI, what's the issue here? And let's check if the contract was deployed or not.
All right. Finger cross.
Okay, it's actually asking me to deploy on the Sepolia. Let's see what was the issue. If we deploy on the COTI testnet,
Hmm.
okay, so I ask it, okay, use the deployment script COTI and deploy this contract Let's check how it behaves.
Yep.
So it goes and update the Hyperlane script to
Mm.
deploy the COTI, and it's trying it by itself. Okay, so it says like it has deployed the contract,
Yep.
and we are gonna find the. Let's try it again. So it gives me this contact address. Let's just quickly go and check if we have deployed the address or not. Yeah, it's on the test net. It's deployed 26 seconds ago.
Awesome.
So it was able to deploy
Mm.
it. It was kind of stuck with the mailbox contract. It kind of got confused because I am providing the mailbox address of the
Mm.
Shapolia.
Mm.
Actually, it was needed the mailbox contract of the COTI, and that was
Mm.
correct. If I'm creating a contract which connect with the Hyperlane
Mm.
on the COTI
Okay.
blockchain, I need to provide the mailbox contract of the COTI blockchain. That was my mistake, and
Okay.
now that's what it actually do. It says
Mm.
the mailbox contract is for Sepolia,
Mm.
and that's why it's like giving me. It has given me 2 or 3 time warning. You are using the wrong mailbox contract. I didn't notice. So yeah, here it is.
So
Now,
this could be one of the issue that you could look out for, while dealing with contract that going across chain.
yeah, exactly. Like sometimes you can think like we are targeting the Sepolias who provide the mailbox of the Sepolia, and that's
Yeah.
actually what I have done, and that was mistake. So
Okay.
here I go and take the mailbox contact of the Koti
Yep.
here, and recipient gonna be same because receiver will be on the Sepolia.
Mm.
So I'll change the mailbox contract, and this is of the Koti now. Let me clear this clutter and try to deploy it again.
Okay. Hopefully this works.
And now let's check what this actually does with the mailbox contract. It logs it here while deploying. It provides the mailbox address and recipient address. Wow. Yeah, that was required.
Mm.
And it says save this address because this is the deployment address. So we have a contract here. Now make a call on this contract. Create a script. Let's see. And when it will go for the interaction, it basically have so many functionalities. Some are easy and some are difficult, like
Mm.
this send message. It takes the message and destination domain, and it creates the message and make the call. I think we should try this one. That's really easy. Let's see what happened here.
Hmm. Oh.
So it kind of try to call many functions, and
Hmm.
we can figure it out from call hyperlane. This one first it goes, okay, okay, here. If we look into it, it just fetch the balance that was right. Contact address, this is also right. This is mailbox and all right. Sending a simple message to Sapolia, where it is. It also shows the contact configuration, and then sending a simple message to Shapolia.
Mm-hmm.
It just created a message and send message. This calls the send message with a gas limit, and it should provide. And what error gives? Error sending message transaction reverted. Let's ask AI why it fails. What happens here? And make call only simple one in this script. So the transaction revert message was actually happens when the contract call has failed. It says like mailbox contact may not exist. That's not the case. It
Hmm.
actually exists. Let's try to figure out if this transaction is in the COTI or not. Or let's refresh this contract if we got any new transactions here. We didn't receive any transactions here. So let's just simplify this script, make a simple call here
Yep.
and simple message. Let's try again. Yeah, it's reverting again. And it
Hmm.
says like it is not getting sufficient gas.
Hmm.
And let me check, double check again if the mailbox contract is right or not. FD708. Oh, FE7E. Yeah, the mailbox contact is right.
Hmm.
Okay, it was not providing the gas fees. That was it.
Hmm.
AI shouldn't have missed that. That was like, because like AI go and compare the function signature, and it should have checked that like this function signature requires some gas.
Hmm.
So still it gives, waiting for the confirmation. It says invalid destination domain, maybe.
Yep.
Check this again. Because the destination domain is correct, maybe the
Mm-hmm.
format it is sending is not right.
Hmm.
Mass's body, it's also correct. So this can be the problem with the contract. Let's
Yep.
check it again. It sends destination domain, default recipient.
Okay. So what's happening here?
Here, let me check the changes again. What changes it has made.
Hmm.
It is saying like the estimated gas, the amount was not enough for
Hmm.
it. So what we can sue, we can provide the extra value. Try to increase it.
Okay. Let's see.
Let's try this one. Okay, which means like the gas is not the issue here,
Yep.
and we need to figure out the contract itself. Create a script to read the mailbox and other storage of contract.
Mm-hmm.
Let's try to figure out a script again to see like what values were saved in the contract, if we are sending to the right mailbox or not. Because if we go here, actually this contract is not reverting the mass, the call is just because it's not getting the call.
Yep.
So maybe let me figure out the contact address. Okay, so this is the contact address we are calling,
Mm.
and we can see this is the amount of fee it is providing. We supposed to provide some fees, and I try to provide one quote, but it's not getting that amount of quote here.
Mm.
So maybe in the script we are failing to provide proper. As you can see, like when your input is not encrypted, you can see it
Yep.
here. I'm trying a simple
Hello world
example to
from
pass
COTI.
to the hyperlane, and
Mm.
this is the input basically.
Mm.
Let me show you in the script. Hello world from the COTI testnet. That's what the
Yep.
message I was trying to send. I didn't encrypted it so anyone can come and read it. So this has happened, and that's the privacy COTI blockchain
Mm.
provides us here. So this is a message trying to interact with this contract,
Mm.
and it says the error occurred during the execution. If we have some logs, no.
Mm.
State, no. And in other transactions, if we try to find out, like it
Oh.
had some fees.
Mm.
Check this one. And if we try to check the first one,
Mm.
had some constructed data. Maybe we can figure out this data here.
Whoa. Yep.
This is the
Encrypted.
contract code. So
Ah, okay. Even the code is encrypted.
no, like this is the contract code. So like this is in a byte format. It's difficult for here to decrypt it, but anyone can source
Okay.
code. Let's go again and
Yep.
run the he read. So it says like this is the default recipient and default recipient address, contract balance. This is the mailbox contract. 7FE. Let's check it again. 7FE 7EA. That's correct. This is on the COTI testnet. That's correct. And we need to figure out if this address is present or not. This is the address we are trying to interact
Mm.
with, and that's also correct.
Mm-hmm.
It is present on the Sepolia testnet. So there shouldn't be any issue with it. So here it comes when it comes to gas limit. What else we can do? Okay. We are going to make our script more simplified.
Mm.
I think the gas limit is the issue here because I don't find any issue other than that.
All right. So are we fixing the gas fee for now?
Yeah.
Okay. Ooh, that's not good.
So like it's making it simplified,
Mm.
and when it calls the function,
Mm.
when we actually call contract, we need to send one
Mm.
ETH. Sorry, it's kind of more as value. It's actually not sending the gas.
Mm.
Let me show you in the example I created. When you send the message, like on the requester send verification, command F 18 check quat. Where is another? Okay. When I'm sending it, I'm sending some value here. I think that can be issue.
Mm.
Let's,
So we're just fixing the red part for now, right?
we have created the contract. We are just trying to make
Mm.
a transaction to show like how it works, but
Mm.
maybe just trying to figure out like how to call a mailbox contract.
Mm.
So I tried to create a very simple examples here, but it still said the transaction execution reverted here. And let me check again the contract of ours. So it's again failed. So the now I think the main issue with the contract, we are missing something, and what we can we can give
Mm.
a last try. So that's how like when AI stops helping you,
Yep.
it's kind of start hallucinating. You need
Mm.
to become like for that in that situation. What you can do, you can go and figure out from examples. You can go and try to
Hmm.
search out the example from the Hyperlane itself. Maybe
Hmm.
Hyperlane have created some examples there, and you can utilize that examples. So let's say what. Okay, I gonna get some examples for you.
Okay.
What else we can do? We can try to create a direct message like this one.
Hmm.
So this have, okay. So I think contract is not working.
Hmm.
A simple function like this with updated details in contract. Try to deploy again.
Hmm.
So it got deployed, and or we need to provide the new address to our call hyperlane. And so it's reverted again, so which means what we can we have tried everything.
Hmm.
What we think we are doing wrong is using this direct receiver message which had the handle function, but
Okay.
I think I don't have the handle function here, the contact I'm using. So for that, what do I need to do? I need to create another contact on the Shapolia, deploy it on that, do the whole
Hmm.
process which I have.
Hmm.
Like, let me show you. Mhm. In the example what I have created. So basically, what actually I'm doing here, I have created this contact on the COTI which have this handle function. And how to create this handle function? You need to put this function signature as it is. This
Hmm.
message you need to decode, and you can get the message from here. And with that message, like you can see, I have taken the message and
Yep.
I have put it on the process verification. It takes the message, processes for you, and make the call on behalf of that. So you can do the same process, and the
Yep.
contract which have that handle function can
Hmm.
actually handle the call. So
Hmm.
then when I created this request function, I have to put this address, the destination address here.
Mm-hmm.
So you need to have both the contracts. What I'm missing here, I am creating a contract on the COTI. I just wanted to make it quick, so to show you demo.
Yep.
But you need to go for the whole process, create the destination contact as well,
Mm.
deploy it there, and then handle it. And this gonna work like this one was working. And you can check the transaction from the Hyperlane Explorer. So when you go to the Explorer, you provide your message ID provided with the Hyperlane as I have shown you earlier,
Yep.
and this transaction going to be successful there, and it will send the transaction to the COTI as it happens here, and within 34 seconds it has submitted my transaction on COTI. So
Okay.
you can also see the steps here.
Mm.
First step is send, then
Mm.
going to be finalized on the chain. It
Mm.
will be
Validate.
validated, and then it relate to the destination chain.
Yep.
So this is how you can achieve the privacy on demand functionality
Mm.
of the COTI blockchain. But you like using the privacy on demand and the
Mm.
creating the private smart contract was easy. As you can see, we have created the first contract, and
Mm-hmm.
it was exactly mimic the contract I needed. It was
Yep.
storing the user's dob, checking if he is above 18 or not. So it was
Mm.
doing exactly what we wanted using the AI
Yep.
itself. So that was easy. You can create a contract on the COTI, but when it comes to bridging with the another chain, you need to
Mm.
use a interchain layer.
Mm.
Hyperlane does it for us. There are so many another option you can prefer from the market, whatever you like. Or if you feel hard, like as you can see, like AI is struggling with the Hyperlane because it's an
Mm.
interchain, maybe it's struggling to figure out which mailbox contact we need to use. In
Yep.
that case, you can also create your own relayer if you are want to use it
Mm.
privately, you don't want to make it decentralized.
Mm.
It's up to you. It's not the platform, the COTI, which is required. It
Mm.
is deployed or developed, and you can utilize the third party or develop by yourself. But
Mm-hmm.
creating a smart contract on the COTI which handles your privacy is really simple. Even with the
Yep.
AI tool, you can create it, and that was the demonstration.
Okay.
And I think that's it for today because the live stream going long. And
Yep.
anything you want to say, Kit?
Well, I think the session is quite insightful. I just want to say that it's very incredible. At least, even though we didn't we didn't finalize the thing, but we can actually see the process of of the whole privacy on demand coming coming across multi chain development, especially when we have the caught the mailbox of the two chains together. It's actually pretty insightful session. So huge thank to Upendra for the demo today. It's I know, like, you must have worked really hard to actually prepare for this, because it's actually a really intense session. I think this is one of the most intense session I've ever been through, compared to, like, the previous sessions that I had sessions with you. Yeah, so thank you, Upendra, for today. If you want to dive deeper into the Web3 and into blockchains, please make sure to follow us. Make sure to connect with us on X, Telegram, and Discord. Also, don't forget to subscribe to COTI Foundation YouTube channel. Please leave a like and a comment down in the comment section below. Keep the conversation going. Thank you, everyone, for joining us. Of course, keep building, stay curious. We'll see you on the next stream. Have an amazing day or night wherever you are. Stay COTI.
Stay coding. Thank you, everyone.
Thank you.